So now let's talk about graphing linear equations. Now, if we're going to graph a line, at its heart, what we need is 2 points. We need 2 points to graph a line, connecting them with a straight edge like a ruler. There we go, we're done. 2 points are what's needed to graph a line. So if we're given something, we did this a little bit in the last video, in slope-intercept form, y equals mx plus b. Well, we have 1 point. We have the y-intercept, and we saw that we could use our slope to graph this line. So let's practice that a little bit. So let's say we have this line, y equals 3/4 x plus 6. Well, in order to graph this line, I need 2 points. Now I have 1 point. I have this point right here. This point is my y-intercept. My y-intercept is at the point 0, 6. That's what it means to be a y-intercept. It's sitting on the y-axis, has x value 0. So if I give us a little Cartesian coordinate system here, okay, so here's a little Cartesian coordinate system that we're going to try and graph this line on. I know 1 point. I know the point 0, 6. 1, 2, 6, which is right here, our y-intercept. Okay? Now I need another point. In order to get another point, one thing I can do is I can use my slope. So here's our slope right here, our slope. And our slope, one way we can think of slope is this rise over run. And that's really giving us a direction. It's telling me, start here and rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. Well, there's a second point. And we can even figure out the ordered pair of that second point. It's at 4, and then we went from 6 and we rose 3, so it better be at 4, 9. So there's the 2 points. We have the point 0, 6 and the point 4, 9, and then we can connect them together to get the graph of our line there. So, hard to see, I'm sorry. So there's one way to graph a linear equation using the slope and the y-intercept. Okay, let's look at another example. All right, so here's another example. Y equals -3/2 x minus 1. So we can think of this y-intercept as our starting point. So the y-intercept is at 0, -1. So down here, so there's the first point of this line, 0, -1. And now we need to get to another point. Well, we can use our slope. Here's our slope, -3/2. We can use our slope to get to another point. Okay, now there's 2 ways to interpret a negative slope. Okay, so in other words, I can think of this negative as going with a 3, -3/4. In which case, this says down 3 and right 4, right? -3 means rise -3, which would be down 3, and then 4 means go right 4, rise over run. I could also put our negative with the 4, right? -3/4, I can even think of it as -3/4 or 3 over -4. Notice I can't think of it as -3 over -4. Negative would become a positive, and this is negative. If I think of it as 3 over -4, that would mean rise or up 3, and then -4 would mean run -4, which means go backwards or left 4. Let's look at what happens if we do either one of those. So if I first think of this as down 3, left 4, I go down 3, 1, 2, 3, and left 4, 1, 2, 3, 4. Okay, so there's a point. And I could connect these on a straight line. If I think of this as up 3 and left 4, up 3, 1, 2, 3, 4, and left 4, 1, 2, 3, 4. Notice that all 3 of these points lay on the same line. Do you have to do both? No, you only need 2 points to make a straight line, but you could do either one. You can think of -3/4 as down 3, right 4, or up 3, left 4. Either way, you'll get the same kind of line that you have here. Okay, let's do another example. All right, here's our next example. Y equals -2x. Wait a minute, I thought we started with our y-intercept. Where's the y-intercept? Is it my equation, y equals mx plus b? I don't have a b. Ah, but there is a b. Couldn't I say plus 0? Does adding 0 change anything? Nah, and in fact, it doesn't change anything so much that we usually don't write it. But here's my y-intercept. My y-intercept is at 0. Y equals 0, x equals 0. So it's at the point 0, 0, or the origin. So here's our intercept. And then what does our slope tell us? Our slope is just -2. Now remember, I can always think of -2 as -2 over 1. That doesn't change anything. So this tells me down 2 and right 1. So down 2 and right 1. So there's our line. Now you could, thinking about that last example, you could also think of this as 2 over -1. That's also -2, which would mean up 2 and left 1. Up 2 and left 1. Still on that same line. Okay? All right, let's do another example. All right, let's look at this example. Y equals 5/4 x plus 3/2. Well, we technically have a starting point here. This is our y-intercept. So our y-intercept is at 0, positive 3/2. And our slope is positive 5/4. Okay. I'm going to rise 5 and run 4. But notice I'm starting at a fraction and then rising 5 and running 4. That may not give me kind of the nicest graph to work with. So another thing to remember when we're graphing is you don't absolutely have to use the y-intercept as a starting point. Really what you need, sorry, I'm going to count for a minute. I should have done this before I started recording. Really what we need if we're graphing a line is we need 2 points. Any 2 points will work. It's often convenient to start at the y-intercept and then get another point using the slope. But for this particular graph, man, that's not a very nice point, 3/2 to start with. You could do it, that would be fine. But let's see if we can do this another way, thinking of the idea that we only need a point. What I'd like to do is find a nice point that's a part of this graph. To do this, I'm just going to do a little bit of calculation, and I'm going to look at some points that are on this graph. I'm going to make an x, y table here. I'm going to pick different x values and see what y values go along with them. Well, we know when x is 0, our y is 3/2, right? How about when y is 1? Well, to figure out what happens when y is 1, when x is 1, I want to know what y is. I'm going to take my equation, y equals 5/4. I'm going to change out my x for 1 plus 3/2. So that's 5/4 times 1, which is 5/4, plus 3/2. To add fractions, I need a common denominator. My common denominator here is going to be 4. So I'll have 5/4 plus 3/2. If I multiply top and bottom by 2, I'll get 6/4. So 3/2 is the same thing as 6/4. 5/4 plus 6/4 is 11/4. So I also have the points here, 1, 11/4. That's not a very nice point either. Blah. Let's see what happens when we plug in 2 and hope we get lucky. We'll have y equals 5/4 times 2. I'm plugging in 2 for x plus 3/2. All right, when I multiply 5/4 times 2, I can think of 2 as 2 over 1, still plus 3/2. Multiplying fractions, we multiply numerators. 5 times 2 is 10 over 4. 4 times 1 is 4, plus 3/2. Now I need to get a common denominator here, but I notice that 10/4 is something that I can reduce. I can reduce 10/4 by dividing top and bottom by 2 to get 5/2. So I have 5/2 plus 3/2. Now I have a common denominator. I can add numerators. 5 plus 3 is 8. 8 divided by 2 is 4. So I have the point on my graph, not 2, 2, 2, 4. This point here. Now that's a nice point. I feel like I can work with that point. So if I start at the point 2, 4, so over 2, up 4, 1, 2, 3, 4, okay, then I can use my slope of 5/4 to get another point and give myself enough points. We're going to pretend I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. And here would be another point on my graph. Okay, we can figure out what the ordered pair of that point is. If you remember, this was the point 2, 4. Okay, I'm going to go up 5. That's going to change my vertical component. I'm going 4, 5, 6, 7, 8, 9. So my new y value is 9. And I'm going over 4. So 2, 3, 4, 5, 6. So this is the point 6, 9. That will also be on that graph. Okay? So what we really need to graph a linear equation is we need 2 points. It's often convenient to start with the y-intercept and find another point using the slope, but you don't have to do it that way. Any 2 points provide you a good graph of a linear equation.